Welcome to Chemistry Concepts with Crip. This video will focus on applying the concepts of potential, possible energy, and kinetic, actual energy, in reference to some common chemical systems that we are going to encounter. Prerequisite to this is the notion of system and surroundings. A system is anything that we can mark as some kind of separate region. The rest being considered the surroundings. Of course, we could also envision multiple surroundings, one within another, in which we delineate a different system. Together, the system and the surroundings make up the universe. Most of the time in chemistry, our system will be the chemical bonds that we are analyzing. If a system loses energy, the surroundings will gain that exact amount. If a system gains energy, the surroundings will lose that exact amount. Let us now analyze a reaction diagram. These diagrams show the progress of a chemical reaction over time. It is important to note that the y-axis is in a negative potential energy well. If it wasn't, there would be no stable attractions to speak of. This first graph goes from less to more potential energy. As such, potential energy has increased. And because potential energy has increased, attractions must have become weakened. But to do this, the chemical system must have absorbed actual kinetic energy from the surroundings. Therefore, the kinetic energy of the surroundings has decreased. Since the kinetic energy of the surroundings decreases, the temperature, the average kinetic energy of the surroundings, must also decrease. Because heat has effectively been absorbed into and by the system, we call this an endothermic process, and the change in heat energy, delta H, is positive for our system. This second graph goes from more to less potential energy. As such, potential energy has decreased. Because potential energy has decreased, attractions must have become stronger. But to do this, the chemical system must have released actual kinetic energy into the surroundings. Therefore, the kinetic energy of the surroundings has increased. Since the kinetic energy of the surroundings increases, the temperature, the average kinetic energy of the surroundings, must also increase. Because heat has effectively been released from the system, we call this an exothermic process, and the change in heat energy, delta H, is negative for our system. Let us now take another common chemical system, that of phase changes in a particular substance. If we take either melting or vaporization, in both phenomena, as actual energy is being added, we notice that the temperature does not change during those transitions. This is because that actual kinetic energy is being absorbed into the potential energy of our chemical system. Therefore, the potential energy of the system increases, and attractions must correspondingly decrease. Notice importantly, however, that since kinetic energy has been both added from the outside and simultaneously absorbed into the system's bonds, that the average kinetic energy does not change. and the temperature remains constant at those points. Because heat energy has been absorbed into the system, we call this an endothermic process, and the change in heat energy, delta H, is positive for our system. If, however, we take either condensation or freezing, in both of these phenomena, as actual kinetic energy is being removed, we notice the temperature does not change during these transitions. This is because the actual kinetic energy is being released from the potential energy of our system. Therefore, the potential energy of the chemical system decreases, and attractions must correspondingly become strengthened and increase. Notice importantly, however, that since kinetic energy has been both released from the system and removed from the immediate surroundings, the average kinetic energy at those points does not change, and the temperature remains constant. Because heat energy has been released from the system, we call this an exothermic process, and the change in heat energy, delta H, is negative for our system. Till next time we discuss the mysteries of the absolute, Crip.